we've finished factorizing quadratics, let's look at another method of solving quadratics. And this has a kind of an added bonus why we would use this method. So this method is called completing the square. It's an algebraic method of rearranging quadratic equation into a different form. And there's two reasons why we would do that. First off, is it's really, really useful to do it like that, and we can solve equations using completing the square that we just can't do using factorizing. The other one is that it gives us a little bit more information about the parabola that's going to be created by a quadratic equation. So completing the square is it's an algorithm as much as anything. So we want to go through a few steps. And we go through that step systematically, and we get an answer out the back. So let's go through those steps. So we take our quadratic equation, so it's in the form y equals ax squared plus bx plus c, and it can have equals 0, may not have equals 0. All right, so we've got a, b, and c. A and b are the coefficients, c is the constant. C, of course, is always the y-intercept. Okay, first step. First step is we are going to move the c over to one side. Okay, either across to the right hand side of the equation, or just like physically move it to one side. We'll deal with it later. You'll see what I mean when I come to do a few examples. The second thing is that we're going to do is we're going to divide every term by a, this a term here, this a number there. So for this one here, and the reason that we do that is so that we get a 1 in front of the x squared. So in this case here, it's going to be y equals a over a x squared plus b over a x, and I'm going to leave a gap, plus c over a. And if we brought the c over, we do it because whatever we do the one side, of course, we have to do the other side. So it may seem a bit strange doing that, but there's a reason that we do that, and it's quite a clever one. The third thing we're going to do is we're going to add b over 2 squared to both sides. Okay, so this is what's called a machina, deus machina technique, which is basically from the hands of God. This term just comes out of nowhere, and it doesn't violate the rules of algebra as long as we do it to both sides, or as long as we kind of add it and then subtract it. You'll see what I mean. Fourth thing we're going to do is we are going to factorize. But now it's going to be really, really easy to factorize the left-hand side, because it's always going to be in the form x plus b over 2 squared. And then we're going to have the other stuff that we created from this step here. We're going to deal with that later. And the fifth part is, I'm just going to move that up a bit. The fifth bit is that we're just going to solve. Let's do some examples. First example I've got here, I've got x squared equals, um, x squared plus 6x plus 5 equals 0, and I want to solve for x. In other words, I want to find the roots of this equation. All right. First thing, we're going to move the constant, which is going to be this 5, over across. So I'm going to take 5 away from both sides. I'm going to be left with 6x, sorry, I've done it again, x squared plus 6x, and I'm going to leave a gap here, equals -5, because 0 minus 5 is -5. Next thing I'm going to do is I'm going to divide everything by a. Well, a is 1, so we don't really care because 1 divided by 1 is 1, 6 divided by 1 is 1, minus 5 divided by 1 is -5. So that's, we don't need to worry about step 2. Now I'm going to add, now I'm going to do step 3, and now b, in this case, is 6. I know my b's and 6's look the same, but that's a b and that's a 6. So 6 divided by 2 squared, so 6 divided by 2 is 3, 3 squared is 9. So I'm going to add 9. And there should be a part of you saying, oh, but you can't really just do it from nowhere. This is a Deus Ex Machina thing. It's okay as long as we do it to both sides. As long as we sort of account for it, the assets and the liabilities add up, the debits and the credits all add up, we're okay. Add 9 to this side, we're okay as long as we add 9 to this side as well. So we're not really breaking the rules, really. We kind of are, but we're not really. All right, next thing we're going to do is we're going to factorize this, and it's going to be really, really easy to factorize. It's just going to be x plus b over 2, which is 3 squared equals 9 minus 5 is 4. Okay. This is a really, really useful form to have it, and I'm just going to put like a little star there. We're nearly there. We're nearly there. Because now if we take the square root of both sides, that's going to cancel and that's going to cancel. And we're going to have plus and minus square root of 4. Now, remember that the square root of 4 is 2, but it's also -2 because -2 squared is 4. So it's going to be plus minus 2. So x plus 3 is going to be equal to plus and minus 2. And now we're almost there. We're going to take 3 away from both sides. And x is going to be equal to positive 2 minus 3. And it's going to be equal to -2, -3, which is -1 and -5. All right. Now I'm just going to just circle this little form here. I'm going to rewrite that like this. X plus 3 squared minus 4 was 0. And I'm just going to park it there. You'll see why I like that form there. Next example. Just follow the rules, the algorithm, and out pops the result. So this one, two numbers that multiply to give us 3 and add to give us -8. This is not going to go. There's no solution immediately to that. So let's do it by completing the square. So first thing is I'm going to do step 1. I'm going to move this 3
over to both sides. I'm going to subtract 3 from both sides. So I've got x squared minus 8x, and I'm going to leave a gap, equals -3. Divide everything by a. Well, a in this case is just 1, so dividing by 1 is pointless exercise. So now I'm going to add b over 2 squared to both sides. So b in this case is -8. So -8 divided by 2 squared is going to be 16, because -4 squared is still 16. -4 times -4 is 16. Negative times a negative is a positive. So I'm going to add 16, and of course I can't really do that. We're going to violate the rules of algebra, but not if we add 16 to that side as well. And now we have our nice little equation that we can solve pretty easily. So we're going to rewrite this as x plus, and in this case it's going to be -8 over 2, which is -4 squared, equals, so -3 plus 16 is 13. Now we're almost there. We take the square root of both sides. X minus 4 equals square root of 13. And then we're going to add 4 to both sides. Plus and minus. And that's going to be our answer. So one of our answers is going to be 4 plus the square root of 13. The other one is going to be 4 minus square root of 13. So next thing I'm going to do is I'm going to rearrange this so that it's in the form x minus 4 squared minus 13. Just going to cut and paste that. You'll see why I'm doing this. Right, the next one has a complicating factor, and it is this it's this 2 out the front here, but that's not really a big deal because we deal with that in part 2. All right, let's just follow our algorithm. We're going to move the c over, so we're going to take 10 from this side and from this side. So we have 2x squared plus 12x equals -10. It's tempting to just divide everything by 2, and you wouldn't go far wrong doing that, but I'm just going to sort of complete this so you can see how that works. Well, actually we're going to do it right now. So I'm going to divide everything here by 2. Plus 6x equals -5. All right. Now what I want to do is I want to take this 6 here. I want to divide it by 2. Square it. So 6 divided by 2 is 3. So that's going to be 9. And whatever we add to one side, we have to add to the other side. So this is going to be x plus 3 squared equals 4. And I'm going to rewrite that, the whole thing now, in this form: x plus 3 squared minus 4 was 0. And I'm just going to leave that there so you can see that that's one way of rewriting that. But I'm going to take the square root of both sides. So the square root of that was the square root of that. So we've got x plus 3 is going to be plus minus the square root of 4, which is plus minus 2. So x is going to be 2 minus 3 and minus 2 minus 3. That's going to be minus 1 and minus 5. And if you have a look at it, that is actually identical solutions to what we had earlier. It's not the same solutions for x, but it's not going to yield the same graph. And that's why I've sort of taken that there. Right, our last example. Complicating factor is this 3 out the front here. It's not really much of a big deal. So first thing is I'm going to move the c over just as we did for every other example. So 3x squared minus 12x equals minus 7, leaving a little gap here. Then I'm going to do b, so I'm going to divide everything by a, and that's 3, so I'm going to divide that by 3. I'm going to divide that by 3, and I'm going to divide that by 3. So I've got x squared minus 4x equals minus 7 over 3. So far, so good. Now I'm going to take b here, which is minus 4. So minus 4 over 2 squared. That's going to be 2 squared, so that's going to be positive 4. All right. Positive 4, and then that's going to factorize as 2 squared equals minus 7 over 3 plus 4. I'm going to take the square root of both sides. So I've got x minus 2 equals square root of negative 7 over 3 plus 4. That's positive numbers, so that's not going to be an imaginary number. It's going to be plus minus that. So x is going to be equal to 2 plus and minus the square root of minus 7 over 3 plus 4, whatever that number is. So this is a third number, so it doesn't really make much sense to factorize it. And that's we can just leave that as our final answer. All right. With that said, let's have a look at these equations that we had before. So I sort of cut and pasted them. This is our first one, this is our second one, this is the third one. Why did I leave it in this form? Why do I want it in this form? Well, the reason that we want it in this form is that when we come to graph them, it's going to be really, really useful. So our first one was the orange one, x plus 3 minus 4. And notice the turning point is going to be minus 3 minus 4. Okay. The second one, x minus 4 squared minus 13. Where the turning point is minus 13, positive 4. Okay. Noticing a trend here. This is what's called vertices form. So vertices form, if we have something in this form, x plus, I think this is h squared plus k, the vertice is going to be at negative h k. So for this one here, the turning point is going to be at negative 3, negative 4. For this one here, the turning point is going to be at positive 4, negative 13. For this one here, the turning point is going to be at negative 3, negative 4. That's why we do that. But we also get to solve, and we get to find where the vertex is. And that's why we do completing the square.